Hello, everybody. So, tonight is something kind of important, but I think most people have probably seen it before. We're going to talk about object-oriented programming, and I think everybody's seen it before, so we're going to kind of work some stuff into that example. Very stripped down, just like that tax module. Right? We only looked at Social Security, and I think everybody knows there's a lot more taxes than that, but that's still just storing the variables and doing the calculation. Nothing new in the syntax as far as that goes, just repetitive process of what we've done. So the object example to work in there will be similar. Like we'll probably put a name field, whereas I think y'all are familiar in the world. We want a last name, first name, social security number, and a lot more than just one field to identify a person, but that's just a little bit more typing and we're restricted for time. So depending on how time goes, the very next thing is we're going to talk about abstract classes. So that might be new for some of y'all. We use the term abstraction and generalize when we're making our classes, just all the time, because that's what we're doing. We're abstracting our data. But there is explicitly something called abstract, which we will look at. I went back and forth this afternoon about whether to just kind of work it into the nice example, but we did a whole bunch of talking the other day. So time to do something, right? So we'll put the example together, and then I'm thinking it'll probably be near the end of the class, but it might be a little earlier or something. But when we update those methods, because it's sort of a building, ongoing example, we'll talk about the problem that actual abstract classes would solve. And we'll see those on the next module. It is kind of nice stretching everything out, so we have lots of time to practice these concepts and think about them and try to make a little more sense. That's the big thing, thinking about them. Because remember, programming is a thinking thing. If software developers don't make the big bucks for typing. People that get paid for typing don't make nearly as much money as software developers. Software developers are getting paid for the thinking. You have to keep that in mind, that sometimes the work, or really oftentimes the hardest part of the work, is just staring off into space, putting your thoughts together. I like to go for a walk when that happens. It's good to step away from the screen, because if we sit by the computer, we'll keep trying different little changes on an idea that didn't work to begin with, may not get us to something that actually works. So it's good to step away. I have about a 2.5 mile walk circle. I walk around Clarksville, but it gives me plenty of time to step away from the computer and rethink the problem before I can touch the keyboard again. Just remember, it's a thinking thing. So we talked about the class notation the other day, some key points: encapsulation, inheritance, polymorphism. So should have heard those words before coming into this class, or review that vocabulary. Introduce the words composition and aggregation. That's something you're going to hear repeatedly as you move forward in class, and it's kind of a mouthful. So we usually say is a and has a relationship. And on the terms, when we're talking about vocabulary, that we don't really use that term. Tonight, when we start putting our classes together, we can go ahead and do the setup with private variables. To make the variables publicly accessible is pretty common in Python, but there are good reasons to keep our data fields private and only access them through the methods. It helps to protect the data, prevent accidents, and there's some good reasons to do it, and it's 2 more key presses to do so in Python. So we'll do that in the class, but I'll make sure and point it out. I think our book covers both ways. But if we're having private data fields, that means we can't immediately access them from the outside. So we'll need methods to retrieve that value, or methods to change that value. And our technical term for that, probably should have been on the notes the other day. That's going to be accessors and mutators. And I just wanted to write these words out here because at various times, there'll probably be a couple multiple choice quizzes that you have to take, certification exams or something anyway through the class where this is the right answer, but that is never what we actually say. Accessors, we want to access that data field. So what we would say is that's our getter method. And mutators, we want to mutate the data held in that named location in memory, what a variable or a data field is. Kind of the same thing, we just refer to them as data fields when they're in objects. And as you progress further along, I'm hoping to find time to connect our Python software to a MySQL database, because every other 200 level class requires that. But for some reason, this 200 level programming class, the ones 200, 210, 220, up to 240, which the language specific ones, this is the only one that doesn't require accessing a MySQL database, and it's really easy. The logic is the same no matter what language, so I'm hoping to do that. So it is not a coincidence that we use the same term for our database tables as we do for the variables in an object. They're very, very connected. In the same way that it is not a coincidence that a lot of the syntax in Python looks very, very similar to SQL code, especially when we do the imports and say from import or from module import something as something. Kind of looks like SQL code. But I got distracted. Mutator. We want to mutate or alter the value in that data field. We're going to change it, or we're going to set it. So the common thing to word that we use when talking to other programmers is that's our setter methods, which are also the names we tend to use in the code when we write those methods. So if we had a variable called X, we would make some methods called getX and setX. But at some point, you'll probably have to take some certification exams or multiple choice quizzes on your way through school, something, and in multiple choice questions, accessors and mutators are the correct term for getters and setters. What else did we talk about the other night? Position aggregation, mentioned that. So we saw a couple methods. Pretty much always want to override the string method. Every object in Python and everything in Python is an object. So everything in Python inherits from this top level master class, grandparent, ancestor sort of object called object. And we get a few things and we'll recognize them because they all have 2 underscores before 2 underscores, then the name of the method, 2 underscores, and then the parentheses. 2 that we almost always want to override are string and equals. Both of them are abbreviated, SDR and EQ. And that's because it's very important to define what it means for our object to be equal to another. The default for equality is stored at the same spot in RAM. And that's probably not what we want from an object. And the default for string, if we just try to print that out, show it in text somewhere, is just the location in RAM where that object is stored. Which again is kind of meaningless to anybody except a software developer, and usually we don't even care about the particular spot that the computer stored it, so it's not even that useful to us. In Python, if we were in C++, it might be a little more useful because then there's a good chance we might be taking direct control of RAM at some point, but we don't take direct control of RAM in Python, so knowing where the computer decided to store something is not much help to us in Python. So we'll see those are the key terms, but for class, I'm going to say getter and setter because that's the standard way programmers talk to each other. So we did a lot of talking the other day, though. That one probably should have been in the notes. So now we can do stuff. And we're gonna start making some classes to define the type of data, a new data type that we need for our example software in class, which you might remember is a stripped down office software. So far, all we have is it calculates the Social Security tax, takes out taxes. But it's an office management sort of software. So the obvious option for a type of data is going to be some sort of employee data. I'm probably not going to get super detailed in the picture here, but I'll kind of follow UML stuff. Employee data, then we'll need some stuff for it. And I'm going to run out of room. I would definitely run out of room on the board if I tried to do everything. So hopefully y'all have heard of UML, everybody's heard of that, I think. Unified Modeling Language. It's an international standard of communication for all things technology. And software developers tend to do more international communication than other fields in IT. So it shows up in a lot of software development courses. It's software developers worldwide, including a lot of software developer companies worldwide. So there's a lot more international communication, which means we might not all speak the same language. So it's a pictorial-based language. Have a bunch of pictures with meaning, pictures that have meaning, so that we don't have to speak the same language. And for object-oriented stuff, one of our main points of starting is the class diagrams. It's a box that tells that describes the class. Some of our pictures are very, very helpful for planning ahead of time. Class diagrams are kind of the other way. It does not take any thought whatsoever to draw a class diagram, so the computer can generate those. Most of your IDEs will have at least a plugin, if there's not something already there by default, to generate the UML class diagrams. However, it does take intelligence to organize them, because we have those parent-child relationships. So employee is kind of general. For the stuff we have right now, what do we need to do? Well, the only methods we have are those tax things. And that needed the employee's name and the employee's rate of pay. So name will go in there. And plus sign means public, minus sign is private. So I'm going to go ahead and do private stuff, but in Python, to make it private, it's 2 more key presses. And if you want it public, just leave off the double underscore before your variable. It's not really private, we can still access it. It's semi-static. So we need the class name along with the variable name in order to access it. But we'll need a name field, which I'm sure y'all can figure out very quickly. We need more unique identifiers than that in a real situation for business. First name, last name, emergency contact name, social security number, tax identification number, driver's license number. They're all a whole bunch of unique identifiers. We're short on time in the classroom, so name will kind of cover that. The syntax for variables isn't that big a deal. It's just more of the same thing. And the thinking it through is unique for every situation, and y'all started to get a good practice with that. So after the name, we want to say what type of data it is. So name's going to be a string. Character text data is the technical term for that. But everybody says string. So even in Python, where it technically has a different name, we still mostly call it strings when we're talking about it. Then we need a rate of pay. But rate of pay could be a bit of an issue. So I chose these two. So back to the thinking thing is, well, a couple subclasses, and I'm going to start like maybe the assumption that all the subclasses are going to inherit everything. And the arrows, this confused me for the longest time. I don't know, maybe one subclass will be called a laborer. So laborer, trying to generalize it for any industry. If there's a business, there's some sort of just boots on the ground labor that needs done for the business. That is a child of employee. For the longest time, it confused me why the arrows pointed up when we always think about inheritance. Because laborer, everything it means to be an employee flowed down this line into laborer, but the arrows are actually polymorphism. Or the ability of one object to behave as another. So what that arrow is saying is that a laborer can behave as an employee. So when we do the higher level planning, like when we go to use this in this class in another piece of software and put our methods together, we want to think about this one up here, and then anything down here can act like that. This is how we apply the inheritance. Then we'll have some other stuff. In my notes, I used clerical. So secretaries, office administration people, so not management. I put management over on their own thing. And that's where the issue with rate comes in, as far as getting into the thinking thing. Like I kind of started out tonight's lecture with software development's the thinking thing. And we want to plan ahead and consider different cases, what's going to happen. We'll also have a managerial branch. I'm going to run out of room. I got to make that smaller. Because most businesses, there's going to be an overabundance of management compared to boots on the ground labor and clerical, the people doing most of the work, right? So we'll have a couple in the middle management, middle MGMT. And upper management. Just to kind of fill out a picture, sort of an example of inheritance and how things apply differently. Is we have a name variable, and in our class diagrams we get our identifier. There's another symbol I'm going to put in that in a moment. Then we have a name. All our data fields, which right now is name. Then typically a dashed line. And then we need public methods to access that. The get name method and the public set name method. Making everything private has some advantages. And the further you progress, the deeper into the details you look at, the more those advantages will make sense. At the early stages, it's kind of hard to see the advantages of them. But more and more advantages will show up the further you get having things private. One of the big ones that's all the way across is it cuts down the chances of an accident. If we can only access that through methods, we're less likely to accidentally change it. The other thing we need was a rate, though. If everything's inherited in this, so now our labor, our clerical, and our managers are going to have the name and methods to get and set those names. We need a rate of pay, but there's a slight problem. Those methods we put together to calculate the taxes use hourly pay, right? Like $40 an hour. That's fine here and here. But management typically doesn't get hourly pay or overtime, right? You get salary. And salary positions, there's often extra work involved. It's going to be more than 45 hours. Overloading happens with salary sometimes, but typically you have to, the anticipation is that you're going to work way more than 40 hours before you get overloaded pay on a salary. So the rate of pay will need handled differently in order to get down to our tax season. Not a complicated way, right? We just take that salary, divide it by 52 to get a weekly amount, and then divide by 40 to get the hour, and call that the hourly amount to feed into the other ones. So it's not complicated, but it is going to need to be handled differently than the other ones, which would just be assigned. So those need to happen down here. So we'll have a private field called rate. A private field called rate. Then our getters and setters. But the rate is going to be everywhere, as are the getters and setters. So it would be nice to put it up here so we don't have to write it everywhere. And that's what abstract classes are, which is going to be a good bit of talking. It's 1, 2, 3, 4 pages of yellow notes for talking about abstract classes and getting you prepared for things for the next class. We go a little bit further in each class. So this class, the big addition is abstract classes. So I think I'll go ahead and put that on our UML diagram. So instead of writing the word rate everywhere, I'll go ahead and give everything a rate field, but I want to handle it differently. So I'll put a hashtag up here to indicate that employee is abstract. Employee will have a public get rate field. Oh yeah, the return types. Name returns a string. Set name returns. Oh, set name doesn't return anything. So it's a void. It just does something, doesn't bring anything back. Get rate though, we can't really say what it's, how, we can't define the method here. So that's why it needs to be abstract. Up here, we know every employee is going to have a rate, but we can't define it till we get down here and know whether it's an hourly employee or a salaried employee. So we can go ahead and define it up here so that everything has it, but we can't define it, so all we have is the name of something. And that's where the abstract part comes in. We can't actually use that class because there's stuff not defined in it. But it's stuff we know that every single child in that class is going to have. So it's a lot better to put it there. And we'll talk at length about abstract classes coming up, but that's our symbol in the UML diagrams. So now everything gets a name and a rate. Name and a rate, name and a rate. But we need some other stuff. So laborer. Should I put it in here? Yeah, I'm going to go ahead and put one more in here because it's something that's coming here in the future of the example. What's something else we get from a job, right? Usually when we get a job, or the expectation is we're going to show up every day and work really hard, day after day after day, week after week after week, month after month after month. Then we need a break, right? So it is very, very unusual for jobs to not give us vacation time. I'm gonna leave vacation time off the managers because they're in salary. Their vacation would be handled differently. But these two get vacation time. So a public private field called vacation. We're not going to use that yet, but we will use that coming up soon. Very soon, we're going to do a scheduling thing. That's part of the generic stripped down plan for when we get GUIs is scheduling. A very stripped down version of scheduling. So at least some variable to put in there and make the calculation a little more interesting. Then obviously you get vacation, set vacation. We need those, but definitely running out of room in the picture here. A department, what department do they work in? That's going to be important for the laborer. The clerical, we don't need to know which department they're in because the clerical ones kind of all have the same thing. Kind of same department, even if they're even in a big corporation where they're spread out in much different places. Like different floors of the same building and different corners of the floors they're on. Those clerical, all the administrative assistants, HR persons, all of them kind of about the same level. But what they do have different is they're going to have different access to the computer, right? Some of them are going to have top level access, and some of them just barely have any more access than the general laborer. So put an access field in here. That's going to give us enough to work with. I'll put a salary over here. And then the middle management and upper management get the salary. Upper management will get a bonus as well. That'll work. But something unique in everything, except the middle management, which in this case, since we have a specific upper management, middle management is just a better name to match that. Oh, makes sense when we put our code together. So sometimes our variable is this, our object is essentially the same data type as the one above it on our diagram, but we might want a better name for some reason or another. Like here, since we have upper management, middle management might be a very useful name. Now get us started. We're going to do the tax things we have written, the scheduling when we get to GUIs, which I think is module 3. The stretch out over 16 weeks, module 3 is still a minute away, isn't it? Our homework for module 2 is due on the 17th, so yeah, we still have a week left before we get to the GUIs. Then we'll do scheduling. We'll go ahead and plan ahead a little for that. They'll give us some stuff to look at the notation. I think everybody's seen this before, and the new stuff is really the abstract. Hopefully that makes sense. I'm going to talk to Link about abstract, including something that we don't really have in Python, but for all those in the software development program, you're required to take the mobile app development class. And whether you go to Bloomington, take Swift with an egg, or take Android programming with somebody else. I think Nick's the only one that teaches Swift, so that's the only unique one. The rest of us all do the Android one. But either way, you're going to need interfaces pretty much on day 1, and we don't have those in Python. So I at least want to talk about them so you're not lost when you get to the mobile app development course on day number 1. And it's very intimately related to the abstract class. It's almost the same thing as an abstract class. It's like an abstract class broken into 2 different pieces, but that is coming up. For tonight, the syntax on doing this. So we're going to put this stuff together. Does anybody have any questions about that logic, the ideas we were just discussing there? Oh, once again, I forgot to start Spider. That takes forever to start too. The other day when we ended up not typing in a code, I remembered to start it, but I forgot today. So it's thinking things, planning, organizing, getting stuff down. These pictures can be helpful. The thing with UML class diagrams though, is that if we go ahead and make our class, it doesn't take any thought to draw that picture. The computer can draw the picture. What does take thought though, is this layout, right? This nice organization of branches, the 3 branches spreading out, the pyramid structure. That takes intelligence. So a lot of IDEs are capable of generating the diagram itself and all the arrows connecting them. But a computer can't put them in a good order. So a human is still needed to organize them nicely and make sense into a fashion we can make sense out of. Because this is a stripped down simple example. Obviously they can get very, very complicated very quickly. So we're going to define a new type of data to put in our objects. Do I still have the files? I think I do. Delete that. I'll delete stuff later. In here though, okay, yeah, I still have all the stuff from GitHub, and I think it was this one. Yes. So here's where we started putting that together. But it's in that file that has the date, and this is an example we're going to keep coming back to. I did not mean to put it in a file that had a date when I created that. So I'm going to just make a copy of that up here in the top level of the stuff from GitHub, which I don't think I've used since the other day. So hopefully it's the same version, but if it's not, it'll just give us a conflict. And when you get a conflict between branches, it's not like it can't be done. It just can't be done automatically. That means a human has to make the decision. There's a lot of stuff that doesn't require thought. And if we're just uploading files and there's a bunch of new stuff added, or stuff was deleted out of an old file, yeah, a computer can handle that no trouble. But if it's not obvious, then a human needs to come in and make the decision. So if we don't see it by halfway through the semester, I'll do it on purpose or something. But I have a feeling it's going to happen at some point because it often does. So I was just going to wait and let it happen naturally. So we have this Pi Alphas thing, which could be set up as a project, like in IDE. There's this button to create a new project, which is essentially a folder and the manifest of how the stuff is organized in that folder. But since this is a learning environment and the manifest in Python is all a bunch of separate easy parts, we'll just do the manifest manually. And, they're not hard to generate, but that way you know what they mean when you generate them and you see those files. And so that's usually there's a bunch of Python scripts that go together. That's what we call a library or a package or a project. And so that manifest file that I asked for with the homework, you only need one of those for the whole folder. And it's something that is background stuff that the programming language itself looks for. So it always has to be named exactly requirements.txt. But a lot of times it is just a blank file. It will just throw an error if it's not there, is the thing with that. So we created this payroll one. Go ahead and open that up so I can find it here. So I'm going to go over to Spider and use this file explorer. Documents, the link folder, all the stuff for GitHub. And here's the one we're working on. So here's our payroll module. Got started on that. And then just like we only need one manifest per project, which is kind of the folder or directory that all the other folders, directories, and scripts and everything else we need for the project is in. Almost just another way to say folder. We only need one web page to document all of it. Website to document all of it. I guess one web page will get kind of cluttered. So we need some data. We have a bunch of data. It might become an organized mess. So what we need to do is create our own data type to keep it organized. and to make sure things flow through the central processing unit and RAM and registers the way we want them to cut down the chance of errors happening. So we'll create one. It is not a restriction in Python, but in a lot of languages, we have to put one class per file. So we do an employee file, an employee class in a file named employee, a laborer class in a file named laborer, and so on and so forth. In Python, not uncommon to put them all in the same thing. You just call it a module, and then we'll import that module all at once. But that's a background data type for us to use. So we don't need to put it in the payroll module because that's something that will be imported elsewhere. If I said that correctly, yeah, I think I said that correctly. We'll split our stuff up and be careful and think through what's going to be imported at different layers of each particular piece of software. I think I'll put all of this data type in one file. There's more specific versions of the data type, such as the difference between a string and I suddenly drew a blank. The formatted version, the one that has fonts and colors included. I'm suddenly drawing a blank on the name of the data type. A step above the string. Sorry, it slipped my mind, and I'm sure I'll just remember it later. But that's beside the point. We have subversions, alternate versions of the data types we need. So we're going to start with that parent one. And our syntax is going to be the keyword class. Let me zoom in a little. The keyword class to say we're designing an object. We're creating a blueprint for a data type. And this one's going to be called employee. And it's going to be abstract, so we'll have to come back and inherit some stuff later, but we're going to do that after we talk about it next week. For now, it's just an object, and we just won't use it directly. We'll just only use the subclasses. Then we need a couple things. We'll need a constructor, the thing that's going to be called that we ask for. We create a new class. I think everybody saw this in prerequisites somewhere. So I'll just kind of go through it quickly. Our constructor in Python is an init, short for initialize. And the first parameter that gets passed in, the Python interpreter itself will pass in an argument to fill the first parameter. And then we fill in the ones after that. The first one you have to remember about comes from Python. And it is a reference to the object itself. This standard in Python is to use the word itself, but that's a variable name. We could call it whatever we want. We could use we could say this silly thing. That's just a reference for us because the first parameter will be filled by the Python interpreter, which means it's actually all going to happen in machine language. So whatever word there is completely irrelevant, but it's fairly standard to use self in Python. Other programming languages use the word this, and those both relate to what it is, the self or this, the object itself that we created, the instance of the thing we made from this blueprint. What do we have? We have a name and a rate. Everything else we'll have to add later. Name, rate. That'll be good. This is the parent on our chart. I think my picture's probably really small, but if I draw up here, remember, this already inherited from object which is an implicit inheritance. Everything does, so it's always implied. So we don't need to worry about passing parameters back up to object that doesn't need any or anything. So we don't need to worry about the stuff going up from our top level. We will when we get down here, because we're going to need to pass some stuff back up to employee. In the constructor or initializer in Python, that's what in it's short for. We have some stuff to pass in. Stands for initializer, but I've always thought that in it just makes more sense for what it's doing. The in it method, what is in it? Well, it has itself. And this one's going to have a name and a rate and the things in this data type. So then when we go to access them, we'll use that keyword. This time it does matter. It doesn't matter what we call it, but once we call it something here, it does have to match down here. So that's the restriction. We can call it whatever we want, but we just have to call it the same thing every time. And if we wanted to say, make name permanently assigned to that object, we would just do .name, which is publicly accessible. Then when we create an instance of this, we'll say like Bob equals employee with the name Bob and $15 or something. And then they would assign that to name, and then we could just say Bob.name to get that data field. And then, so it's public, it's accessible from other software. That's a key point, that when we say outside of our software, is accessible outside of our software, that always refers to other software. You don't want to think about the human. The human can only access it, humans can only access it through other pieces of software. So public means accessible to other software. There are good reasons to call it name as your studies progress further and further, and experience in IT progresses further and further, and you learn more and more about it and have thoughts rattling around in your mind for a while and develop better understandings of what the machines are doing. The reasons to make it private, there'll be more and more of those show up. So we'll go ahead and cover private, but if you want to make stuff public and do it easy, just leave off the 2 underscores. In some of our other languages, we actually have to type out the whole word private. So it's a whole bunch of letters to type. But here it's only 2 key presses, so it's not really harder to do this. And once we set up our data fields, then the standard is Alt Insert to just generate all the getters and setters, which where is written on the board. It was written on the board because I intended to point at it at that point. And I guess I forgot that and erased it. But getters and setters don't take any thought to make. We're gonna make a couple here in a second, and you'll see why it's the perfect sort of thing for a computer to generate. And we're gonna assign to that data field that belongs to this object that name thing that was passed in. Same thing on rate. Oops. Self.__ rate is the rate field that was passed in. Oh, I forgot that up there. I said it, I just didn't do it. And then anything else we need to do to set up. That's the initialization. That's the starting. So we might need to call some of our other methods in some instances. We might have some data fields that don't need passed in because we already know what they are. Default things, and every situation is unique. So there's other stuff, but anything we need to do as soon as we create a new object goes in the init method. Well, now since those are private, we need a way to get those. So we'll create our getters and setters. So they always look right like this. Get name. This method is going to access a variable and bring it back. So we don't need to pass in any parameters. We don't need to pass in any parameters when we call it. However, like I just mentioned a moment ago, the Python interpreter does need to pass in a parameter. So when we're making it, we have to leave a spot. We don't want to forget that spot that the Python interpreter has to pass stuff into. Usually called self, but whatever you want to call it. And then after that, then our getters are just accessing that value. Right? It's like, what is that private value that's held in there? So all we need to do is return that. Return self dot underscore name. And getters always look like that. Get the name of the variable we're getting. It doesn't need any extra parameters passed in. It's just going to return the value. Same thing with setters. Define about a method called set name. On this case, though, we will have to pass something in. Well, we're changing what's in that data field. So obviously we're going to need to pass in whatever we want to change that to. Sorry, Zoom is absolutely determined to show me the message box that says the audio is not on. You need to connect that. So it is now starting to put that message box where my mouse is. Hopefully what I just did will get that out of the way. So that's what our setters always look like. Set the name of the method. In Python, C family, and Lisp. We don't need to in R. Don't need to in SAS. But there's quite a few languages where we have to make that reference to the interpreter or compiler or whatever's going to pass in. And some we don't need that one. And the point I was going to lead you with that is this looks awful similar. Right? We have a name there, and Spider's really good about the highlighting and predictive text, so it knows that name's different than that name. But it looks similar. Something to keep in mind is that only looks similar to us. Looks very, very, very different to the machine. So we don't have to make up another term, another thing to call it to avoid repeating the names. The computer will never get them confused. As long as it's, unless we're actually doing two separate things. If it's two entirely different things, we don't need a name for it. So our getters and setters always look like that. The standard is Alt Insert on your keyboard will generate that code after you have all your data fields set up. I don't think that works here. Let me check. Alt Insert. Nope, nothing happened. So it's a different keyboard shortcut in Spider. But more IDEs use Alt Insert than don't. So now our other getter and setters define get rate. Oh, this is abstract. I'm going to wait and do that later. And we'll make a method called get rate down here. And we'll talk about the abstract stuff next week. Yeah, that works. So all we can do is change the name and then we'll put the other stuff later. Oh, we need the string. Define underscore string underscore needs itself. And this is what happens if we say print employee. Our Bob equals Bob's a new Bob equals employee with that some name and some rate of pay. And then we say print Bob. What comes out? Probably one of those things. We're short on time. There's an error I usually like to throw here, or a few steps from here. But I'm just going to bypass it and check this for yourself sometime. So all we're doing is returning something to, like, say, the print method or the concatenate method, the cast as a string method. Oops. We want to return, and when we put this together, you'll want to use the methods. It'd be fine if we were here, but it makes a big difference down here. So whenever we start using, once we have those getter and setter methods, you always want to use those. And when time allows, like during your homework or just random practice with Python, give that a try using the private data fields directly versus using the getter and setter methods, and look at the error that happens. It's just a type error. It won't recognize those private fields from the child class, even though they're there. But we're short on time here, so let's y'all can throw that error on your own and see what it does. It's good to throw errors on purpose sometimes just to see what happens. The idea of making small random changes to see what happens is good for the learning process. So what does it mean to print an employee? So let's say self.getName. So I'm going to use the Bob example. So Bob plus makes plus self.getRate. I guess I do need to get rate. Get rate. Oops. Self and why did that just run? Self returns self dot underscore rate. Because once again, our getters and setters always look like that, kind of the same. And when things are always the same, that's the perfect task we want to just pass on to the computer. Self.rate equal is assigned rate. There we go. Now I can use it. So Bob makes this much. Oops. Oh. Plus per hour. That's about all we can do for the string right now. But something that tells us something more useful than the location in memory where that's stored. Now we can make the child classes. I'll start over here on the left. So that's our basic data type. We have employee data. But we can get more specific instead of trying to do everything at once. More small objects is better. That's just the general trend anytime we're feeding instructions into a machine. More small things are better. If it helps, think ones and zeros. A computer can either do a small step or not do that step. And nowhere in that exhaustive list I just read off was there anything mentioned about a big step. Right? A computer can either do a small thing or not do that thing. And that's pretty much what we have. When I'm programming microcontrollers with port manipulation, I don't even think 1 and 0. Because of the way I write the code, I actually think 1 and not 1 as I'm writing them to keep track of it. Port manipulation is actually directly controlling the registers. So that's things like register 86 gets a 3 in bit 7. Register 20 at the same time, register 23 gets a 1 in bit 4 and a 1 in bit 5. That's how we get the most speed on microcontrollers, but that's a side point. When I'm programming those, I don't even think 1 and 0. I actually think 1 and not 1. And there is a microcontroller lab. I think everybody, that's a distraction. So back to this. We have our general data type, but we need more specific ones, such as, so we'll do another design for a data type. This time we'll make something called laborer. I don't know if I spelled that right or not, but if I spelled it wrong, as long as I spell it the same way every time, which when I need it, I'll probably pull it from the predictive text list. So I may never type it again. So spelling doesn't really matter. The computer doesn't know how to spell it. But as I look at that, I think I spelled the word laborer wrong. And we want laborer to inherit from employee. So our syntax for that in Python is just to put the parent class in the parentheses.
You spelled it correctly, by the way.
Oh, I did? Okay, thank you. Thank you. Something looked wrong when I glanced at it. Maybe it's spelled wrong on my notes, or that happens sometimes. To start with, we put the parent name in parentheses. There's some other stuff we'll do that is in the list of odds and ends for the end of the semester. So we have a laborer. Once again, we need that constructor, the initializer, or we have to say what's in it. It always has itself. Over here on the picture, laborer is also going to get the vacation days. And the department they let laborer away in. Oh, but also going to get this stuff from the parent class. So we need a way to get that back up to employee. So the typical way to do that is we need args and quarks. Once again, those are reference names. We could call them whatever we want. A Christmas break, Christmas vacation of 1989 when he was creating Python to begin with. He used args and quarks. The important part is the asterisks or two asterisks. Args are all of the single data fields, which in this case, all we have is single data fields. All we have is name and array. Essentially, one variable things each. Quarks are keyword arguments. That is all our collections. So sets and lists and dictionaries and tuples and generators, and I think function, depending on how we pass the function in, a function in as an argument, it could fill out either one. The way I usually do it, it goes as a part, but we could pass a function in as an arg as well. But single things go in args, collections of things go in quarks, and that's all the stuff that we don't want to write twice. That way we don't have to write name and rate here. And if this has another child, we don't have to write name and rate vacation and department again. We can just use those passing things. They go right up to the super method. And it's an there's an inheritance thing. So, oh yeah, you can see on the predictive text what the super method is expecting. I like to use the parent-child terminology for this because it makes more sense, right? You have more access to your parent's house than the average person does, right? Same thing with the parent-child term stuff here. The child class has more access to the parent than the average piece of software. So it can access the parent's constructor directly and pass those args and quarks right back up. And then do its own thing. So self.vacation equals vacation. Self.department And notice that I have started just reading that variable name, even though those underscores are there. It gets to be a mouthful. Whoever asked me for a class where we cover loosely typed languages, there's dollar signs everywhere, and you'll just see me read the stuff written after the dollar sign. Because it gets to be a mouthful to say that everywhere. I'll do the same thing with underscores here. Instead of underscore department, I'm just going to say self.department. Then we need some getters and setters again. Or for formal multiple choice quizzes like certification exams, remember accessor and mutator. And from those terms, you should be able to easily think back through which one's a getter and which one's a setter. You're going to access or get the vacation. That should really be vacation days. Oops, I put my cursor here. And Control R. Let's make that vacation days. Replace all. There we go. Most text editors, that's either Control H or Control R. Sometimes it's something else. It's not an official, it's not as standardized. It's Control C and Control V. But usually it's Control H or Control R. As in hand and recycle. I guess those are a couple words. Do one of those. So the getter doesn't need anything passed in. It's just going to return vacation days. So vacation. And the setter or mutator does need something passed in. And I always like to use the same word to help cut down on confusion of what's what. Obviously, those are reference names that is immediately being applied to something else. So it doesn't really matter what you want to call it. Same thing on the others. I'm just going to copy and paste that. So copy that, paste it, and instead of vacation days, get department. And change this to department. And again, change this to department. And this to department. And then both of these to department. Fix that typo up there. Wait, was there another? Oh, I haven't saved yet. I probably should have done that by now. Oh. Okay, if you set it up as a project, then it will automatically go to save there. That's another advantage of projects and packaging is the IDE will know what file you plan to work on. This one I'm just going to call employees.py. This is going to have all our employee types. Why is there an X there? I don't see the problem, so I'm just going to retype it. Oh. That's the setter. That's why. Oops. I did the same thing down here. Okay. We don't need to return the setters, but that gives us access to those private fields. And for now, the string method that we inherit will be good. So set up the other data types, the clerical. Because now we're just into the tedious typing busy work. Most of the work in software development, what we actually make the good money for is the thinking. And we've already done that. So now it's just the tedious busy work. And actually the computer can type a lot of this. I have a script that is, I've already wrote a script that can do all of this just repetitive typing like this. What's clerical get? Vacation days again. And excess. Oh, as well as args and quarks, which get past args and quarks, get passed right back up to the parent class, directly into the constructor. So, I'm going to copy this. That's going to be exactly the same. Which means that would have been a great thing to go right here in our picture, right? We could have stuck that in there, just a little intermediate thing. Not a non-management class, have vacation days, then we wouldn't have had to type that twice. We can clean that up later. That's kind of what's known as refactoring. Just cleaning up the code afterwards. So along with vacation days, we need access. Oops. And access. Set access. Because sometimes people need more access than the HR department originally gave them, right? Oops. Got a little ahead of myself there. The manager class manager. Oops. Again, inherits from employee. Needs an init method with a reference to itself, a salary, and then the stuff that goes to the parent class. But a little bit different this time. Because args and quarks are getting passed back up. That one of those is the rate, right? We need to calculate the rate from the salary. So we'll just pass that back up here explicitly. So rate is going to be the salary divided by 52 weeks a year, divided by 40 hours a week. And then that will work with all the general methods we put together for hourly salaries above, or sorry, hourly rates of pay above, even if it's a salaried employee. And then just because this might grow later, we'll still pass up args and quarks. Because it's a lot easier to put it in now, even if they're going to be empty, than to come back and put it in later if we end up needing it as things get updated. Well, then there's not really anything else to do for the manager. is the rates taken care of. So it's gonna get the get name, set rate, set rate, all of that stuff from the employee class. The only thing that was new was it's a salary instead of an hourly rate. So when you have a useful name, but then it's a salary, so we have to convert that to an hourly rate. Then we have class middle management, which inherits from manager. So middle manager doesn't really get anything, so we just, the only parameters we need are the ones that are going to get passed up to the parent class. Nothing else to assign there. It inherited everything. The only purpose of that was a useful name to match the other type of management. Our code will make more sense if we have middle management and upper management than manager and upper management. So just a naming thing. And finally, class upper management. Again, inherits from manager. We'll need a constructor, the reference to itself. Ooh, a bonus. It's good to be the top dog. They get a bonus pay on top of their salary, which will just get passed in with arbs and barbs when we initialize it. To be passed up to the parent object of manager, which then gets passed up to the parent object of that. What's the new field? Bonus is bonus. Then we need getters and setter for it. Okay, that was a lot of typing very quickly, right? We're up to line 96, and we started this at until. So 25 minutes to do 100 lines of code. And I was talking, and I'm sure I went down, tried to go down a rabbit hole or two there. But now we have our own explicit type of data that we can use. Does that make sense? I believe everybody's seen that before. The new stuff is the abstract stuff that we'll talk about mostly on Tuesday. Another place where we use the hashtag symbol in the UML. Obviously not in the Python, because I would just comment out that line and it wouldn't do anything. Might want to do some this stuff, get that website set up, but we're running short on time. We've seen how to do that, right? Just adding comments in a certain fashion so that we can generate website documentation, and we do that later. We've been at this for a minute. We just need to use this somewhere, because now we have that specific data type. Now we can improve our payroll. I've been excited for this because there's so many just overly generic examples. Everybody here tonight has had a class before. So many overly generic examples. Now it's finally like an example that, even though it's very stripped down and made to fit in our time constraints, it's starting to lead towards more what it's like to really develop a piece of software than random assignments out of a book or those stripped down examples just to cover the syntax and talk about some key points. We've thought it through and defined the data that we need explicitly, which this is America. In many senses, America is a giant business. So for this data type, y'all probably have all kinds of ideas about wanting to correctly, right? You have all sorts of ideas about a better way to organize that. And it would work, but this is how the process for developing software. We start by kind of mapping out our general idea. That's what we did the other day with functions. But now we can improve this, because the other day, we just took in some string data. Employee and rate of pay. Like, let's not do that. We have some custom data we can use. Import employees. People, employees. I'm going to change that, sorry. From employees, import everything. We know what's there. We don't need to specify it. This is the way I usually prefer to do the imports. When it gets converted to the byte code before going to the interpreter to be turned into assembly language, which then gets turned into machine language. The computer will kind of pre-process that and replace the wildcard character with the comma separated list that actually gets used in our program. So in the end, it's the same as if we would have typed from employees and import upper management, comma lower middle management, comma clerical, comma laborer. Because the computer will do that before actually running it. I usually use the import notation in class just to help accentuate where things come from, but we just wrote this. We just wrote these objects, so we know what they are. We don't need to accentuate it. Because now we don't need two numbers passed in. We don't have to rely on somebody giving us the data type that we need. We have one piece of data we need. Employee. And so how I do this? I might change this around before next week, but we can pass the thoughts there. We can pass in this employee. I just came up with an idea that might be a better way to do this. And then from that employee, we can get their name and calculate their taxes and all of that stuff. Yeah, I'll do it like this, but this kind of needs to jump ahead. Because once we have that, we need to access the stuff from the employee, and when we pass it in like this, we can't tell, the computer can't tell that it's this type of object yet. So we need to wait till we have an abstract class. So I guess I'm jumping the gun on that. We'll improve this when we get there, except that from an open type language like Python, where you have a parameter fill, when we send something in, the computer doesn't know that it's this type of data. So if we came down to here to say line, where is it here? Line 39, it said employee.rate.getRate. Or here we put in employee.getName. The IDE is going to show us an error because from an arbitrary parameter, it doesn't know that. That's something we will fix when we get to abstract stuff next Tuesday. So now we go over to, I guess the test file is where we need to change it. And we'll, wasn't there a test file? Is it somewhere else in the folder? Zoom stuff's in the way again. Oh, yes, that's right. I put it in another folder. I'm just gonna move the test stuff in here too. Yeah, I put it in another, I remember. I put it in another folder so we could go through that whole process of adding the pad. So I'm just gonna copy that one over to. So since we've seen that, now I'm just gonna go to the easier way to do it and have our test file in the same thing as our libraries, and we can just delete those delete the test file at the end before we release the software. There we go. Now I can open that up here. So we had all this stuff, but we can abbreviate this a little more. So employee 1 is now going to be a new laborer. And what do we have? Name is equal to Bob. Looks like his rate's already in here. And it can be, if you use args and quargs, you'll want to go ahead and label everything. You can match the appropriate order, but it gets a little confusing and it's an extra thing to keep track of. That they can free up your mind to dwell on more important issues just by putting that label in there. So it's a good form to do so. Even in the cases where you wouldn't have to actually do that. I'll go ahead and put something here. Because Bob gets a vacation. Vacation days, July 4th, which a few steps from now, I already have this whole thing planned out. So we will be doing, we'll actually need an actual date, not just a string at that point, but we'll get to that later. And actually we need a list or a dictionary or some sort of collection of dates because vacations are usually more than one day. Department, that's that one. And Bob's department is, I don't know, labor. Just making something up here. And, oh, it doesn't know what labor is. Because, oh, we haven't imported that labor. So from employees, import all. No one knows what labor is. And remember about that sys.pat thing? It's very useful. You always go do that first. Probably wouldn't be a bad idea to reference our own library here, but Python will always look at the folder we're in. That's why working in the same folder makes things easier. So there's a couple, we can abbreviate a couple of these. So now instead of several employee 2s, there's Sally's clerical. Sally's the administrative assistant. She gets that rate of pay. What else does she get? Vacation days. It's important to keep the secretary happy. That administrative assistant happy. They are critical to a business. Some people forget some people lose track of importance in a company and think that it's got to be way over here. But in a lot of the cases, or actually, I'll just go ahead and say, in pretty much every case, you can and will be replaced easier than a good administrative assistant. That's a good thing to keep in mind for young people starting out in the business world is a good administrative assistant or secretary is the word that tends to flow out of all of our mouths, even though we know that there's a nice formal term for them. But no matter what you are or what your role is, you can and will be replaced easier than a good administrative assistant. So they usually rank pretty high in taking order around a company the way things actually happen. Maybe not on the paperwork that they fill out and keep straight and everything, but they're usually very important for it. Yeah, we're gonna keep the administrative assistant happy so she gets vacation days whenever she wants. She wants a day off, that's fine. What else is there? Oh, access. Access. I put VIP access. When we get to that point, that's several weeks away. There's going to be different levels of access, and we'll need an encoding for it. So I'll just do that for now. Let's see, what's next? Becky. Well, Becky's pay looks like manager pay, so I'll make her upper management. And everybody's seen this before, right? I just started using this syntax without actually checking that. Oh, so look at the list of names here. Yeah, I know for certain everybody here has seen this. They create an instance object. So we give it a reference name. It's going to be assigned the name of the object, the class name, and then we fill in all of the parameters. Send arguments to fill all our parameters. The rate, she's up for management, so she doesn't get any time off, but she gets a bonus. Her bonus, let's say 20% of sales. We'll make that a number later so we can do math with it, just putting something in there. That's good for our example. And we still haven't got this cleaned up to a list yet. There's only 3 things, so 1, 2, 3. So when we're less than 4, and here we'll do imp1 dot get name. Whoops. Because we need those methods to call it. Likewise, imp1 dot get rate. And then that number gets passed right in there. And we print it out. Imp1 dot get name. Employee 2. Once again, we can just put dot get and as parentheses. Dot get rate, add parentheses. Dot get. So I'm typing kind of fast there. Does everybody see what I was doing? Anybody have any questions about that? We already talked about what all this stuff means, so now we just need to change those old variables out for these, but the names should all make sense there. We don't have an employee 4. Oh, I still gotta do employee 3. And this will look much, much better when we get lists, which I know everybody in here has seen lists before, but sticking somewhat with a nice slow schedule. Employee 3 dot get name. Sorry, I'm gonna make a change here. We put the string method in there. We put what it means to print this directly. So we'll get the name, who makes this rate, and then never plugged into that sentence. So all we need to say is we want that object. Get name was older, but that's one of the things we made our own custom data type so that we would have something better than just putting their name in there. And now check for typos, which I'm sure there are some. If you have the choice, it's always a good idea to run in a dedicated console. Then you don't have to crash your whole IDE. If something goes wrong, you can scratch that little the tab with the console or terminal or shell or whatever you're running in. Let's see, one missing parameter required positional argument access. Oh. Access should be spelled with a lowercase a. Try that again. Oh. Notice, so there's the arcs and quarks. Our upper management is saying we didn't give Becky a salary. We put a rate on there instead of a salary. So we didn't want that. Let's change this. Oh, I don't know, 43.21 an hour. I think that's around 45,000 a year. It's getting late in the evening. Well, you can plug that in the calculator and just pick a good salary. So if you want some testing values, does anybody see what I missed there? Any comments? I've made this mistake enough that I definitely know what that's from. Yeah, for a salary, I got the calculator. So you could just say like, okay, I want to test with 45,000 a year. So I know what those taxes are, and then just run through your equation. 52 weeks a year, 40 hours a week. And that comes out to 2163. Oh, so I guess that was about twice that. So she's making like 90,000 a year. No comments on what I missed there? I recognize it because I noticed it. Oh, also, there's underscore manager underscore in it. So there should be 2 more underscores. That's the problem. But that whole thing right there, it referred to it with the class name. So if we want to access these private variables, they're not really about private in Python. We can say, well, in our case, Becky dot manager dot underscore manager underscore salary and access that directly. So it's usually just when we see those, it should be treated as a private variable. Oh, well, I don't see thought that's what it was pointing towards. But it looks like it's typed everywhere. So what's that saying? Oh. There it is. That's what I thought it was. I just looked right up past it. Y'all know this steps. Oh, there we go. Just type everything up, type what you're thinking, go back and fix the typos, and then see if your thoughts work correctly. So how much did Bob, how many hours did Bob work? Oh. Oh. So the casting thing, which the print format string wouldn't really work for us right here because we need the methods. The child classes will inherit the methods, but the child classes can't directly access the parent's data fields. So we have to use the methods here. Let's see. Any other typos? It's already went longer than I hoped it would. All right, that worked. Sally worked 27 hours. Looks like that worked. Now this question is going to need updated. Doesn't matter how much Becky worked, right? She's the boss. Maybe she only worked 3 hours this week. Something looks wrong there. So that's an issue we'll have to fix. Because if anybody's on a salary, we don't want that to happen. But we can't necessarily do that up there yet. Here, yeah, we'll have to add some code in to fix that, right? We'll need the, we'll have to add some code, but there's only 10 minutes left on our schedule tonight, so I can do that later. Or you all can probably quickly do that, right? You hopefully see the code that needs added. Right now, it's calculating for everybody's thing, so what we need to do is check and see if we have a manager type. There's multiple ways we can check that. But if we have a manager type, we want to get salary, not the hourly rate. We don't need to worry about their hours. They make the same thing every time. And my plan for it is to make manager abstract as well, but not until after we talk about abstract classes on Tuesday. We went over the syntax for it, but I think everybody's seen that before. That little bug there at the end, you should be able to easily fix that. It's just a selection structure to see whether we have a manager or not. And the best way to handle it is with abstract data classes. Abstract base classes is the term we use in Python. So you'll notice we mix those parent, child, super and sub, base and derived. We use all the terms. I guess it really just depends on the preference of whoever put that code together, or what they felt like doing in the particular day they put that part of the language together. So we will see that abstract stuff for a better way to fix that. Y'all can probably come up with an easy one. The main idea was the classes though. Everything's saved. And since scripts are software usually involves multiple files, usually want to make sure you hit the save all button, not the save, that way everything's saved, but here it's grayed out, so it should be good to go. So the normal go back them up. Go to documents, delete folder, get the zoom buttons out of my way again. Go and get stuff. Right. Git add doc. So add the current directory. Because it's already connected to that branch. It's still there from last time. We didn't have to re-download it. It's still there. It'll be there next time, so we don't have to do all the initialization again. Git commit with the message class notation. So there's our changes. New folder because we moved that stuff over, organized it a little bit differently, copied and pasted some files, made that new stuff. That looks good. So push that back to the origin on the main branch. And it looks like it's back on GitHub. So clear, exit. And close the IDE for today. And notice if you keep that GitHub stuff on your local computer, you just have a connection to there and you can move stuff back and forth whenever you want. If I go to the top level, point at that. This folder, it's a hidden folder, so you have to turn the hidden folders on to see it, but it has all the GitHub stuff. So as long as that's there, you're still connected to your GitHub repository. Anybody have any questions about stuff from tonight? We will see more of that soon. I know that was stuff you've probably seen before, that the SDEV 140 class might have got up that far. It at least went up to the class notation, and then the inheritance is the big thing. We're studying encapsulation at the intro level. Now we're going to add in inheritance and polymorphism, and a big part of that is defining which classes are abstract and which ones are concrete. And we'll see that on Tuesday, so that'll be some new stuff then. There's no questions. I guess that'll be it for this evening. All right, y'all have a great weekend. If you have any questions, let me know. I'm always happy to help. There's 5 minutes left on our schedule tonight, so I assume if there's no questions now, they're not going to show up at 7:50. But you can ask me questions anytime. I'm always happy to help. And I will see you all next week. Y'all have a good one.
Thank you. Have a good weekend.